I'll start the recording. Okay, back again for another installment of doing React and stuff. Um, this lesson is kind of a mixed bag. We have, let's see, performance, TypeScript, testing, and project structure. And um, the assignment covers part of it. It's kind of all over the place, but um, yeah, Um, I'm not going to do like slides before because I didn't make slides, but I will walk through the assignment. And if any of y'all need me to stop and explain things or any of that, I'm happy to do it. And I tend to have a lot to say, so I'm sure I'll end up talking about everything either way. But um, yeah, if anyone has any questions or anything throughout, feel free to stop me and I'll do my best to explain. Um, but yeah, we're just going to be walking through this together and kind of winging it because I haven't fully uh, done all this stuff ahead of time. I did part of it, but okay. So I'll screen share. What is this? Sure. I recently updated my computer. The new version of Mac OS came out, which is cool. So, but as part of that, there's a bunch of like permissions things that got reset. So something I've been realizing. It even broke some of my code stuff, upgrading my operating system, which I think is pretty typical. Um, that's why there's things like package managers, because it just in general, when you're upgrading different things on your computer, it can break certain things. And so, okay, so um, performance, TypeScript, and testing. Um, I didn't read any of this. Looks like a lot to cover. So I'm just going to skip over that. Hope that's all right. Um, and we're just going to get into the actual things that we're doing. So the first step is improving the project structure. So I'm sure you all have realized by now, like when you're working on a React project, you end up with lots of different files and folders, and it can get kind of unruly. And there are certain kind of standards for how to organize them. And it's good to kind of learn I guess, like the standard practices or best practices for organizing your project because um, that way it's more familiar when someone else wants to work on it or moving from project to project. You have some consistency there. Um, and so here we'll be creating a new folder called components and just putting a bunch of our React components into that folder.
I don't mean to stop you so quickly, but has there been to-do container anywhere else in this project? Because it says stretch goal, you may not have this in your files. And I tried to look back in every week to see if I could find it by control F, control finding, but I couldn't find it. So I just want to know, is to-do container a brand new thing to this week, or am I like missing out on something?
I have no idea. I don't
There is
remember
a mess
seeing it.
there is a message from Roy in the Slack channel. He basically says if you haven't created it, just ignore and use the components from the app.jsx.
Well, where did it come from?
It could have been an older version of the curriculum. I noticed sometimes they like update the curriculum, like kind of one assignment might change, and then they don't update the next assignment to, reflect the changes. So
Okay.
it could be that they like used to have this as part of their stretch goals and then they took it out.
Okay.
Um, so yeah, I'm not sure exactly, but uh,
I just
we're
need some confirmation because I was like, what is like, did I do something wrong? Did I miss something? Where's the stretch goal? But thank you.
Yeah, I sympathize with that. You definitely it's hard when you're learning how to code and some details seem really important and then some you're like, oh, that was actually just a mistake and I could have glossed over it. So, yeah, for this is something I would ignore. Uh, it's a stretch goal that you may or may not have. Sounds like they didn't even have it in this go around. So, yeah, we're gonna ignore that one. Don't get too hung up on it. And then that too, we're ignoring that. Um, but yeah, good call out. This step is very pretty straightforward and simple. So uh, yeah, basically we're just taking a bunch of files and putting them into a folder. And the one tricky thing about it is we need to make sure that our imports are still working. So we import files, and when you do an import, it's relative. There's like a file path, and so the file path needs to be updated. Um, and my editor, like VS Code, I don't know if it's an extension or just by default, but it will update these for me when I move files, and it'll update the imports. And sometimes it works perfect, and sometimes it like misses one. But um, yeah. Anyways, we'll just get into it. Um, Also, I did copy the instructions into a README file here, so I don't have to be jumping back and forth. Um, and really quick, if you want to know how this works, basically there's a language called Markdown. Let's see, where's my read? Am I blind? Oh, there it is. I also recently got a new extent or a new icon theme, so my icons are different now. I'm just trying it out for fun, but I'm realizing that it's harder to find the files that I'm looking for because I don't have that like um, familiar thing to it. Um, so yeah, README files are written in a language called Markdown. So you can see the .md extension that stands for Markdown, and Markdown looks like this. It's kind of like code, but what it really is it's just like it's one step above plain text. So like a plain text file would just be text and there's no formatting. And then a markdown file allows you to annotate your text um, with certain like there's certain things that mean certain or that will result in certain things. So this hash, the hashtag, that means a heading, a level one heading. And so when you actually see the result of that, it looks like this, a level one heading. And then the two hashes is a level two heading. And then this is how you do a bulleted list. So it's this language called Markdown. And basically it takes having a Markdown viewer. So VS Code has one built in, so you can actually see it. You can see the code and then the result of that code as rendered. So Markdown is a common syntax for creating what's called rich text. So this would be considered rich text. It's just like normal text, except it has formatting and stuff applied. And so something like a Word, like Word and Google Docs and stuff, those are rich text. And Markdown helps you create rich text in code. So that's what I did. That's how I got this in here is I copied the assignment instructions and put it in here. Anyways, I'll try not to go on too many tangents. I always seem to do that, but oh, I already did this. Let me rewind back to before I did it. So, yes. Okay. So imagine I didn't have that folder. I'm going to make a new folder called components, and then I'm just going to move those files in there. And then when it asks to update the imports, say yes, and it'll basically any file that imports these components, like app.jsx, hopefully it'll automatically do it. But if it doesn't, then you have to go and update these imports here. So before the path was something like that. It looked like // which means look in the current directory relative to this file. So it'd be looking in the same file that app.jsx is in, which is this source folder. Side note, directory and folder is the same thing. Those terms mean the same thing. Directory is just what like Linux people call it. I think it was the original term, and then folder became like the more standard thing that people call it, but same thing, directory and folder. So the / means look in the current directory and then look for this file. And this file, cat list, no longer exists in the current directory. It exists in the components directory, which is within the current directory. So you update it to look like that. / components / cat form. And this syntax, it should look familiar if you, are familiar with navigating in the terminal. So like in a terminal, you do a lot of stuff. You do a lot of stuff regarding like moving around, like navigating between different folders and files and stuff. And so you can do like cd, change directory, and .. means back one. And then // you don't have to put // but it's more explicit, and that means go into the folder at the specific level we're at. So those are terms, or that's like the language of file paths in Linux. So we're moving all of these components into the components folder, updating their imports in app.jsx, and then if you have your app running, which you run it by doing, you forget, it's npm run dev. And then you can take that URL, paste it into your browser. I always do it in a incognito tab because it makes sure that you don't have any extensions running. If you have browser extensions, and browser extensions can sometimes add weird things to your page, and like it can like show things in your console that are weird and stuff like that. So I always do a incognito tab because it's like a clean slate for your app. So we're checking that our app is still working, and it is. After you do those imports, if it's not working, then it's probably because you need to update your imports. So if I delete that, so it doesn't say components add cat form, it just says add cat form, it'll give us this error. Let's see. Failed to resolve import. So it can't import that. So we go and we do components, wait, / components. And there we go. Okay, pretty simple. We're just changing the location of these components into a folder to organize it and updating the imports. And yeah, this is a common pattern in React, is having a folder called components. And then as you add more and more and more, you might like split it up even further. Looks like I have some things to read in the chat. Let me just double check this. Oh, what extension does that? The automatic importing. I was actually looking into that. I have an extension called TypeScript importer, which I thought it just worked for TypeScript. And let's see, there's that one. I think this is the one actually. Move TypeScript. This might do it for JavaScript too. It kind of, I feel like it only does it for TypeScript. Maybe it does it for JavaScript too. If you're not getting the like auto import thing, then let's see. Maybe I'll look it up. VS Code extension update JavaScript imports. VS Code can automatically update import paths when a file is moved or renamed. The feature is controlled by the JavaScript update imports on file mode enabled setting. Okay. Now this is just AI telling us that, but it might be right that there's a setting.
I am going to bring you off top for a second. How do you feel about the Google just shoving AI in the search engine and not allowing you to just, go search for an answer because I felt some type of way about it. I just wanted to know.
Like having this AI search result at the top.
Yeah.
I like it personally,
Okay.
but I see, I have I think there's things to like and things to not like about AI. Personally, I think that sometimes it kind of makes it faster to get to the information you want, but sometimes it can be like misleading or, so it's always good to be like cautious. Like when I was looking at this, I was like, okay, this might be the way to do it, but it might not be, and I don't know. What's nice about the way that Google does it is they have the sources. Like where does it get that information? It shows it right here. So you could actually go into one of these and double check. But um, okay, so let's see. Is this a setting that you need to turn on? I guess really quick, I could show you how settings work in VS Code. If you go here, you go to settings, or you can press Command dot. Oh, oh, I might have changed the hotkey. Oh, that's not it. Oh, that key I just pressed is going to do some weird things. That's like a performance thing for my computer. I don't know. Oh, it's a command comma. That's how you bring up settings. Yeah, I thought that was a period, but it's a comma. So command comma, bring up settings. There's two different ways to view your settings in VS Code. One of them is in this like view here. And then one of them is by pressing this gear icon. You can see this is this is the same settings. Or actually, this is just settings that you have set, but you can access and change all of your settings, all the same ones that are in here. This is like the visual interface for changing your settings, but then you can also change them in code here. And this is JSON. So the format of this code is the same as like your package.json. If you look in there, it's the same type of format. And you'll eventually get used to using this format if you aren't already. It's a pretty common format. And it looks just like it's mostly basically just like a JavaScript object, but you can change settings in here. And so I'm going to look up that setting. Doesn't look like I have it set. So I might go try one here. JavaScript update imports on file mode. Um, so looks like setting that setting. And the reason I know that it actually exists as a setting, even though I just found it from AI, I'm getting IntelliSense right here that shows me what it's all about. And then I'm also getting like autocorrect in here. That So I would change it to always, and then it always updates your imports in JavaScript files when you move the files. And if that's not working, then I'm not sure what the problem is. I'm sorry.
How do you get to the settings JSON again?
So you go to settings and then you click on this little gear icon. It might not look like a gear for you. I might have a different icon here. I'm not sure. Sometimes the like icon theme you get for VS Code can change the look of things, but there should be some sort of button or something to view it as JSON. And this probably has an associated property in like the normal settings menu. So if I looked up update import, if I go here and I go update import on file move, yep, there it is. And if I change this here, it'll change it in here too. It's the same thing. So if I change that to never, and I go here, there, you can see. So two different views to see the same information. But yeah, you can look up this update imports on file move and change this to always, or prompt. Oh, prompt is default. Okay. Anyways, if that's default, then I'm not sure why it wasn't working for you, Amanda. I'm sorry. But try setting this setting. If it's something else other than prompt, then maybe. Also, it sometimes just doesn't work. Sometimes I move files and nothing comes up. Okay, moving on. So we took all our components and moved them into the components folder. We didn't take all of them though. So that's kind of the ones that we put in here are ones that are kind of like sub pages. So you might, like, if you start learning Next.js, which is kind of like a framework that uses React. Next.js will have a components directory, and then you usually have a pages directory, or with the update, they have an app directory. And then basically it'll be like you have your screens in here. So this would be like homepage.jsx or something. And then so you'd have your pages in one directory, and then you have your components for those pages in another directory. That's something that we're not, we only have one page here, but anyways, that's kind of one way that you might organize it. Okay, back to the assignment. So we updated the imports, and that's working now and good. So now we're going to install the prop types library. So in JavaScript, you don't have strict type checking, which type checking is like, I mean, it's a whole thing. It's related to like TypeScript is related to that. And if you know anything about TypeScript, then you understand this. It's this idea that like a function or anything in your code will have specific like values that it'll work with and values it won't work with. So like, for example, our components here, this add cat form component, it only works if you pass in an on add cat function. So this is like a handler function. So this prop, if you want to use this component only works if you have that prop. If you don't have it, then it won't work right. And same thing with this cat list. If you try to use the cat list, but you don't have any props, it won't work right. Like if I save that and then I go to my app, yeah, I'm getting an error. And so there's this thing, this is something that TypeScript solves, where in JavaScript, you can use a component and you can use it incorrectly. You can take a component and you can either pass in no props or pass in arbitrary props. You can pass in all the wrong different things. And your compiler or like in your editor, you won't see anything wrong. Like you won't get any red squiggles when you use this component wrong. So here, this is the incorrect usage of cat list, and you're not getting any indication in your code editor that there is something wrong with how you use that. In TypeScript, that would give you a little squiggle. It would tell you you're doing something wrong. It's going to say you're using the cat list, but you're not passing in the required properties. And so that's something that TypeScript solves, but for now, we're doing like this is like the light version of TypeScript. This is like the not actual TypeScript. It's just adding something similar in JavaScript. There's this library that is called prop types, and it allows you to make sure that you pass in the right props to any React component you use. So it's a separate library. And basically what it does is it makes sure that you're using components right. And right now, if your app is running fine, then it's not really going to add anything for you. But what it will do is like if you extend your app in the future and you're like adding new things to your components, it'll ensure that like you don't actually mess things up on accident. So it's a third-party library, and we install it by running npm install save props or save prop types. This is another way to install it, yarn add prop types. That's if you're using Yarn as your package manager, but I'm not, and you probably aren't either. You're probably using npm. If you are using Yarn, then you'll see like in here you'll have a file called yarn lock, but in here we have package lock.json. So that's how we know we're using npm. So we're going to use this. Yeah, don't run this command unless you are for sure using Yarn. Use npm. npm and Yarn are just two different package managers. They do the same thing. Okay, so we're going to install this package using npm. Remember, that's what npm is like kind of made for, is managing your packages, and it can install new packages. And a package basically is just some third-party code, some code that someone else wrote that's out there in the world that you can use in your code. So we're going to install this third-party code called prop types, and npm helps us do that. So run that command. We're not going to worry about this. You might see this type of thing coming up. This basically is just telling you there are two vulnerabilities in packages that you have installed. So we have packages, and each package might depend on other packages. And so you end up with this huge, in your node modules folder, you can see you end up with all these are all different packages that people have made. And the reason they're all in your project is because one will depend on another, and then that'll depend on other packages. And then you end up with this whole tree of different, and so that's why node package manager exists, because you don't want to have to deal with all those different dependencies on your own. But when you see there's like vulnerabilities, that means one of those packages or multiple of them have vulnerabilities. If the warning level isn't high, or there's like an extreme warning that comes up that's like critical. And if it's that, then it might actually break your app, but for the most part, you don't have to worry about it. Okay, so we now have that installed, and you can verify that by going to your package.json, and under dependencies, you should see prop types. And then this will be a version. So this is probably the latest version of prop types. And that's what we want. And now that we have this library in here, this defines which packages our project depends on. And then when you run npm install, your node modules folder will actually end up with all the different packages. But we don't have to run npm install again, because when we installed this, we installed it using npm install. So anyways, now we have the prop types library, and we can actually use it in our code. So how do we use it? Well, add to do for, okay, so we're going to go to our add cat form. Actually, I should be using the README that I added here. Okay, so we're going to add to do form, which for me, since I have a add cat form, I'm going to go to add cat form. So add cat form. Okay, what's next? Import prop types from the types package. Oh, okay. So we're going to import probably, yeah, I have to do that. And then prop types. I recently enabled GitHub Copilot again, so I have GitHub Copilot, the AI programmer thing. Okay. This is not okay. See, GitHub Copilot is not actually helping here. It's telling me the wrong place to import it. Prop types from where is it? The prop dash types package. So prop dash types. And then actually let me go to their actual, yeah, you can click on here to go to their actual GitHub to see how they do it. Okay, so this is the import. This is how it should look. So we don't need the curly braces around it. And it should be capitals like that. So it should look like that. Okay, we imported that. Now, below the add cat form function, define the prop types property of that function as a new object. Okay, so the add cat form component is a function, right? Because it's a functional component in React. And then we're going to define prop types as a new object. And they don't, looking at here, they have like in the example that they have for this, they have a class component here. I think it's going to be the same for a functional component. And if anyone sees me do anything that's not correct, then feel free to correct me. Because I did this once a bit ago and then I forgot how I did it. But I assume it's like this, right? So you say add cat form dot prop types equals an object. Let's see, does that line up with what they say in the README? Define the prop types property of that function as a new object. Okay, yeah. So our function is this component, add cat form, and we're defining a property on it, which you define a property on an object by using the dot selector. You can access it or assign a new value to a property, like create a new property. So we're creating a new property on our add cat form component called prop types, and then we're assigning it to an object. And then this object is likely going to have some stuff in it. So inside that object, define a new property with the key on add to do. So that's the name. And then the value, so key and value. The key is on add to do, and the value is prop types dot func. Okay. So on add to do. And actually here I have it on add cat. So it's going to be on add cat. And then it's going to be.
Okay, two quick questions. So conceptually, all prop types does, or TypeScript does, is you just basically saying what that thing is. So you have wrote add cat form, and that's the not that's the component, and then you are identifying it with the prop types, and then you're just going in and saying, okay, the add cat, this is specifically this type of thing. because whenever you check overlay it, it just says any because it doesn't know what it is, and I'm assuming adding this, and when you overlay it, it will say, oh, this specific prop is this because you have designated that prop as that within this code.
Yep, exactly. You're exactly right. So, um, yeah, so we have our on add cat form, which needs to take in a certain prop. The prop should be a function called on add cat. And right here it's saying on add cat is any. Um, and this is a TypeScript thing, by the way. TypeScript is actually VS Code has a TypeScript LSP, which is a language server protocol. I know a lot of words coming at you, but the TypeScript language server protocol is actually allowing your VS Code to infer what types certain things are. But in JavaScript, it's going to just assume most things are any type because because in JavaScript, you're not specifically declaring type of different things. So here we're saying this on add cat prop right here should be a function. So we're saying on add cat form should have a prop called on add cat, and the type of that prop should be a function. And this is specific, this language here is specific to this library that we're using, this prop types library. If you're doing it in TypeScript, it would look a little bit different. But it's a similar idea. It's basically saying whenever you use this on add cat form function, you'll get some red squiggles that say you're not using this right if you don't pass in an on add cat prop, and that on add cat prop isn't a function as we define right here. So make
Okay.
sure that when you're using something, you're using it correctly.
Okay. So, but the overlaying text won't update based on what you added,
I am not
essentially.
sure, honestly. Let's see. On add cat. So let's see. Okay, I'm not getting any squiggles yet. Let's see. I might need to do more things. Add
Okay.
prop types from the prop types package below on add to do form, define the prop types property of that. Oh, wait, I was doing it in here. Run your application in view in browser, verify that your to-do list still appears correctly with no console errors, and then repeat the steps for the different components. Okay. It did have an error, but that was probably like there intermittently while I was changing stuff. Now it seems fine, no errors. So doing this didn't seem to do anything. Let's see. Maybe it will give us an error. I mean, I'm surprised that it's not giving us type hinting. Like if I do that, I'm surprised that it's not giving us any errors, but I guess that's like um, a limitation of using JavaScript instead of TypeScript is that even though we're using this prop types package, it's still not going to give us any squiggles. Unless we're not using this package right. But maybe it'll give us an error in here. Nope. Okay, what? Okay. Maybe it's because I changed that in ESLint. Let's see. Yeah, React prop types. So I added this and maybe I need to delete it and then maybe I'll get the right thing. So basically I was getting this ESLint error and I'm pretty sure most of you, if not all of you, were also, which was complaining about prop types. And that's what this is potentially solving. What this line right here did is I added this to say, hey, ignore that I'm not using prop types. Ignore it. Like, don't worry about it. Don't give me any warnings because I'm not using prop types. So if I delete that, now it probably by default will give me warnings if I'm not using prop types. And so then this might solve it. Whereas, so if I delete that, and maybe I need to reload. you can reload your VS Code window sometimes, and sometimes that'll help with things. The way you do that is Command P or Command Shift P, I think is how you open your command palette. I changed it on my computer, but pull up your command palette and then search reload window, developer reload window. And that'll sometimes help if you're getting like weird errors that are showing up that shouldn't be there. And it might just be like outdated. It might be that the LSP hasn't updated yet. Okay, so we can see that did actually change it. So on add cat is missing in props validation. So it's saying we're not actually validating that this function is going to have this on add cat thing. So that's when we go back and we add. Oh, I deleted it. I think I can just undo, right? Oh, no. Okay, I have to redo it. Yeah. There we go. GitHub Copilot to the rescue. Cool. Okay. So now that makes the error go away. And let's see. I'm wondering if I use this. Okay, so it still doesn't tell me here whether I'm doing that right or wrong. Oh, maybe that's where it helps. Your IntelliSense will now tell you if you add that on add cat. Anyways, I'm not sure exactly what this prop types package does. All I know that is that it's kind of it's a workaround to add some type validation without actually using TypeScript.
Okay, so
Yep.
I don't like to do the thing that people always do. Like, why when are you going to use this? Because like it doesn't it like if it doesn't show anything and it doesn't actively, I mean, I guess if you do is required, it forces you to make sure, right? That's how this works. Because it didn't like I'm watching and it didn't seem like it really showed like it was doing anything. And even when you overlay it, it didn't seem like it was doing anything. So like um what is the purpose of prop types?
Um,
Like when I guess in production, when would you be using
this
price
is my
type?
first time ever using this library, so
Okay,
I'm sorry. I just that's like
that
a
that's
limitation
fine.
of my knowledge right there is
That's fine.
I
I
don't fully
mean,
understand.
it happens with code all the time, just there's so much code out there, it's fine. I just wanted to know like if there's like a production real world application of prop types.
Yeah, my guess is that if we like added another prop here called like uh my cool prop, because I disabled that ESLint thing, this is where it's helping us, is it's saying um it's missing props validation. And so I would need to go down here and say my cool prop is a string, sure. And then my hope is that, which this hasn't been working, where it should be that when you're using this component, I would expect that it should give you some sort of error if you're not adding that prop. But um, it could be that it treats them as optional by default. Or actually, no, because we have is required. Maybe I didn't have is required on odd add cat before, and so maybe if I reload my window, it'll actually give me a little squiggle. Nope. Okay. So yeah, I don't understand what what the use is for this library, but okay, let's see. We might have some explanations in chat. From what I understand, it's a development aid so that by the time you get into production, you're not passing in incompatible data anywhere in your code. Yeah, that's my understanding too, but I would expect that it would give us an error when you're actually using the component itself, and it's strange that it's not. Like I would expect that we're using this on-add cap form here, and we're not passing in the props that it wants. A step towards learning TypeScript. Yeah, that's possible. Yeah, sorry, I don't have an answer, but it's preparing you for learning TypeScript, I'd say. That's probably the best benefit you're getting out of this. There must be a better way to integrate this. Run your application. Okay. I'm not going to repeat that with these. Sorry. Maybe instead of doing that, I'll really quick just show you a little TypeScript demo. I'll show you how this stuff works in TypeScript. And maybe I'll show you an actual TypeScript project, just so you can see some TypeScript in action and in an actual React app. So I have here a, and I know this is probably going to be overwhelming because it's kind of a big project and there's lots of TypeScript and lots of new things here probably. So I'm not expecting you all to understand all this stuff, but just to give you like a high level overview, just so you can kind of get the lay of the land. This is a project that I've been working on that's a portfolio of mine. I'm actually, do I want to? I'll show you. I'm in the middle of a rewrite for it. So it's not in a great state at the moment. But this is a Next project. So it's using React, but it's using a framework on top of React called Next.js. And Next.js is like, it's React, but with a bunch of additional things that are better for like a full stack application. So there it is. This is my dorky avatar that I made that
It looks nice.
people told me it doesn't look anything like me, and I kind of agree. I probably need to change it, but
So cute.
it's in the middle of a rewrite, this whole site. But anyways, this website, and I made it in Next, and it's using React and also TypeScript. And so I'll show you just, I guess I'll start with showing you the file structure, the folder structure, and how that relates. So in Next, we have, in your project, you have a source folder, and in Next, you have an app folder, but it's the same thing. The app folder has different pages, and so you don't have to use React Router to make different pages. You actually make different pages by making different files, which is kind of easier. That's more like the way you do it in vanilla HTML, CSS, and JavaScript. So I could go to like one of my main components. I haven't even opened this project in a long time. What is even going on here? I guess everything's in UI, huh? Yeah. Okay, so we could go to my hero section. These are all TypeScript files. But basically, what you can see here is this isn't a very good file to demonstrate. Let's do header. Okay, so I have I made a mobile header and a desktop header. So the mobile header would be this. So it has that. And then the desktop header is this with these links. And so these are different components I made, mobile header and desktop header. And in each of these components, I defined props. So an interface is like a type. An interface basically is like defining what values need to go in here, basically, in the case of React. And so here I'm saying, if you want to use this mobile header component, you have to pass in an avatar, which is an object with a URL that's a string, and it has to have a class name, which is a string. And so here, this is where we're destructuring the actual props. Now, if I try to use this mobile header incorrectly, if I forget to pass in the avatar, for example, we'll now get an error. And it's TypeScript telling me property avatar is missing in type blah, blah, blah. Okay, so we have one prop defined, but we don't have avatar defined. And so I can start adding avatar, and it'll give me the IntelliSense. It'll know that I want to add that. And I can actually prompt TypeScript to tell me what to add. If I do that, it'll tell me avatar. And then what should avatar be? Well, I can hover over it and it'll say avatar should be an object with a URL, and the URL should be a string. So I can say URL, and I'm going to say blah. Oh, wait. I need to do an object within an object, right? There we go. And now it's happy. And now it's not going to complain anymore. And so the benefit of using TypeScript, or one of the big benefits, is that when you're using a component in React or a function or anything in your like JavaScript code, or your TypeScript code, all of a sudden it will tell you if you're doing something wrong before you even run your app. Like you don't have to go and see that you have errors in the actual, application. You can see in your code editor whether there's something wrong. And so you basically define how everything needs to interplay between each other. And so like if I were to define a function here, just for fun, let's do function add. Let's do add. It's just a generic function that adds. And I kind of want to turn off GitHub Copilot. Yeah, let's do that. Disable code completions. Okay, so we're going to add, and then we can take in a number and another number, and we're going to return the numbers added together. Oh, wait. num1 plus num2, return num1 plus num2. So TypeScript is going to start complaining already. It's going to tell us, what's wrong with this function? Well, num1 implicitly has an any type. So the type of num1 isn't being like specified here. So this function basically could take in, what if we said add, and then we passed in null and an object, an empty object. If we use the function like that, this will not work right. So when we define the function, we want to say which parameters will this function actually work with? Well, it'll work with numbers. And so this is a specific syntax for TypeScript. So TypeScript allows us to define types for different parameters. So now when we use add, it'll say argument of type null is not assignable to parameter of type number. So we're trying to call this function, but we're passing in null instead of a number. So what if I add 1? Okay, now it's complaining about the next thing. An empty object is not assignable to number. Okay, so we can add 2. And now it'll be happy. And we can even say, we can do a return type. We can say this function returns a number. So now in add, it always has to return a number. And now, what if I did if true, like blah, 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 if true, return hello. I'm just doing this for fun. Or this is just for demonstration. It's going to complain now and say type string is not assignable to number. So there's a certain case where this function might not return a number. And the case is if true. So it'll always not return a number. It'll always return a string. If I did 10, now it'll be happy. I add a semicolon. So in your TypeScript, it'll actually look at every branch, every like if statement in your function and all that. And it'll say, is there ever a condition where this function won't return a number? If so, it'll tell you about it and complain. And then when you're writing your code, you never have to worry. If I were to do like const result equals add 1 and 2, TypeScript ensures because this function, when we define it, it makes sure that we always return a number from this function. We know that result will always be a number. It can never not be a number. And so there's a lot of things in your code, like in JavaScript, where you might accidentally end up with like the wrong value. Like, you know, you write the function in a way to where result somehow ends up being undefined. And then you try to do like, you know, result plus plus. Oh, wait. Okay. Let's do let. So you might do result plus plus. And if this was undefined, if we did like return undefined, I'll make this function to where it can return a number or undefined. So now it'll say result is possibly undefined. The return type of this function is either a null or it's either a number or undefined. Here, we're saying it's going to return undefined. So either this function returns a number or undefined. And now we know result is either a number or undefined. And now when we try to do result plus plus, it's like, well, there's a case if result is undefined, we can't do this. This will cause an error. And so then if we take that out, so it has to return a number, now TypeScript is making sure that our function always returns a number. And so basically what it does is not only does it help in cases like this, where you have a function and it's going to make sure that the result of the function is exactly what you want. It's going to make sure that every variable is exactly what you want. It'll help you even in like React stuff. It'll be like, you know, you're using this component, but you're not passing in the props that it wants. Like if I were to go here and I would try to pass in a prop called like, you know, ID equals, you know, 1, 2, 3, it'll complain and be like, sometimes the errors get kind of crazy. So these props are not assignable to the props that are available from mobile header. Some benefits of using TypeScript. It's more verbose. It takes more time to write, but after getting used to it and your code base gets bigger and bigger and bigger, and like, you know, say you like take a break. You haven't worked on your project for a while. Like I haven't worked on this project in a long, long time. So I come back to it. I've already made sure that I don't pass in the wrong prop types to anything. So it basically just it verifies that you're using every function, every variable, everything in your code, and makes sure that you're using it correctly before you even like go to run it. So that's the benefit of TypeScript. Okay, let me catch up on chat. I see prop types as a way of having more consistency in the code because by defining the variable type, you can avoid certain errors in which a variable expects one type of value and receives another, besides giving you warnings while developing. Yep, exactly. Yeah, so defining prop types is one step towards what we're getting here in TypeScript. Found a good example of where prop types are useful. It throws a red line in our assignment this week. If you'd like, I can screen share. Oh yeah. Yeah, Amanda, if you want to demo an example when prop types is useful, that'd be awesome. You can do it now or later, either way.
Yeah, I'll share now.
Okay.
Remember how to share my screen.
Maybe I need to stop sharing. I'll stop sharing.
Mm-hmm. There we go. Okay. So I was on the next step of our homework moving forward, and I was putting in the prop types under input with label, and I just set it to function for both of the props for input with label, which you can see here. And as you can see, there is a red line thrown under to do title. And if you hover over the input, it shows you that it's not a function that's coming in, it's a string. And when you come back over here and change that to string, red line's gone
Oh,
because
nice.
you've now got the correct prop type listed below input with label.
Awesome. Cool. Thank you for sharing. Yeah, that was exactly exactly what I was trying to find is it correcting you when you pass in the wrong thing. The way I have been testing it is not passing in the prop at all, but I guess it treats all the props as optional. And then when you pass in a prop, it verifies that you pass in the right type. So a string or a function or whatever. So yeah, thank you for sharing. And I might spend one more second on this because I one of the biggest benefits of TypeScript that I got excited for when I started learning it, that I just think a lot of people don't explain is the IntelliSense you get when you're using a third-party library. So I'll share and I'll show you really quick if I can. Let's see. Actually, there's a project I should show you called Pass. So this is a project that, oh wait, this isn't using TypeScript actually. This is using JavaScript with JS docs. Which JS docs, they look like this. This is like another version of having something like TypeScript in JavaScript. It's these big comments that basically tell you what types certain things take in. They look confusing, but it's basically doing the same thing. So this was like an open source project that I was working on. And so say I go in to work on this project, there's a bunch of other people that have worked on it too, and um, I want to add something. So they're using all these components. I don't know how to use any of these components. Let's say I want to add a box. So I'll say box, and I'm like, man, I don't even know how to use this component. I've never used this component before. Maybe I need to like go and look at it, or maybe it's a third party component. Maybe this comes from like a library, an external library, and I don't know how to use it. I could look at the documentation for how to use it. But another thing I could do is, because this has JS docs, which is similar to TypeScript, I can get my IntelliSense to pop up, and it tells me which things this component will take in, which apparently is a huge amount. That doesn't help me that much. But on a component that doesn't take in all that stuff, let's see, is there any? Maybe not. Typography. They're probably all going to be like that. That's probably the result of it being a JS docs project. Let's see. There's another one. Let's do next dashboard. I want to find a component that's like a third party thing. No, there's one that I might not be able to find one. How about this? Okay, yeah, this is using TypeScript, and it's probably using some third-party libraries, so this will probably be a good one. Okay, router provider. Button. There it is. Okay. Styled button. This is not a third-party button. I'm really any of these? No. Okay. Sorry, I'm trying to show you an example of using a third-party library, and how when you're using a third-party library, it will tell you which values you can pass in. But for some reason, I can't find a good example here. None of these projects are using any third-party libraries. But anyways, yeah, oh wait, next auth example. That's got to be one. Modal routing. Sure, this might be a good one. Okay, so this is a demo where I was using some components from Next.js, I think. Getting all sorts of errors. Okay, so I'm using a link from Next.js. And I know like we can ignore all these errors, but okay, it's not giving up. Too many errors in this project. Okay, forget about it. Sorry, y'all. I thought I was gonna be able to find a good example to show you how TypeScript gives you this amazing IntelliSense to where you can basically see all the props that something needs to take in just automatically. It'll like tell you, but okay, we're gonna move on. So we looked at prop types. We looked at organizing your project structure. Now let's try this. Let's do the unit testing with Jest. So I have not even looked into this yet, but we'll go through it together. So in code, you can write tests, and tests kind of verify that your code is working automatically without you having to like go and see the website, which you should go and see the result of your code either way, but it can test things that you it can be more fine grained and automatic and all that stuff. So testing is good. And if this is your like first time seeing testing, then welcome to the world of testing. It's like a whole thing. But so Code the Dream has this like demo repo for this assignment that we're gonna click on code, copy to clipboard, and then go to your terminal. And I'll change into documents. I think I have a Code the Dream folder. Let's do Hawk demos. There, that's good. Okay, so we're in the folder now that I want to clone this repo. And I'm going to do git clone and then paste that URL. And then I'm going to cd into that. So that is called ctd jest unit testing practice. And then I have VS Code configured to where I can open VS Code at the current directory from my command line. So I can say code dot, and that will open VS Code at the current folder. And if you want to know how to set that up, VS Code has an article about it. Open VS Code from terminal. So launching from the command line. So you open VS Code, open your command palette, and look for the shell command and install code command to path. And then that should do it. So you do shell command, install code command to path, hit that, which I already did it, so I'm not going to do it again. But that will enable you to open VS Code from your terminal at any point by pressing or typing code and then the folder that you want to open. Okay, so now we have this this project open, and we're gonna see it. It has some tests, and so it's using this testing library called Jest. Jest is the JavaScript test library, so JavaScript test Jest. And looks like they have a series of functions that are supposed to do certain things, calculating Fahrenheit to Celsius and Celsius to Fahrenheit, and get first string from array. Okay, so they have these different functions in here. They're exporting them, and you have to export them if you want to test them, because your testing code is also going to be JavaScript code, and it's gonna test these functions, and it has to import them. So here they have an index.js, which is where their actual JavaScript code is, and then they're testing these functions using this index.test.js. Just config, that's like a configuration file, which you don't have to worry about. And so to test it, I think VS Code has some integrations built in, but I also have some extensions which help with this stuff. Like I can click on run, and it actually, like these little things that show up, like run, and this thing here, these are like ways to manually run a test. That is extensions that I have. There's one called Jest Test Runner, I think. So I would install some of these if you want. I would install Jest. and jest runner, and I think that's all you need. And you don't actually need them. They can help with, give you some extra stuff. And then also I have it set up to where my terminal automatically opens a thing that's testing, which it never seems to work for me. I don't even know why. I didn't set that up. It's just there. But you can test code by running usually an npm command that is specified in your package.json. And it's usually just test, and then there's test watch. So I could run these tests by saying npm run test. Oh, okay. I need to do npm install first. So when you clone a new project and it has dependencies, which this one does, it has jest and some other stuff. It installs any of those files. Oh, and here you can see I have 2 critical dependencies, which that's typical of like an older code base, because usually people will find vulnerabilities in code and then you patch them. So you update the packages will get updates, and then you update the packages in your code. But if no one has updated, if no one's worked on this project for a while, then they would, if any vulnerabilities are found in packages, then you won't have been updating them because you aren't working on the code. Don't worry about it though. It probably shouldn't break anything. But okay, so I did npm install. So I did git clone, and then I cd'd into the repo, opened it in VS Code, did npm install to install any third-party packages, and now I'm going to run npm run test. Okay, and that's what it looks like when you test code. It shows all this weird stuff in your terminal. We can ignore this. This looks like an error for an outdated dependency or something. Okay, so the first thing to look at is fail. So a test or a function related to this file failed, which we only have one file right here, but one of our tests failed. So the test is called Fahrenheit to Celsius conversion. And this is like a specific run. So they ran the function, expected 32 degrees to be 0 degrees Celsius. So they passed in 32 degrees Fahrenheit, expected the function to return 0, and it didn't. So it gave us an error. This one works. So that's kind of how it works. So we're testing this function, and then these are the 2 test cases. One of them failed, one of them succeeded. And this is another function they're testing. One of them, or both of them failed. Another one looks like this function is all good. And then it gives us some more information. So this is like the overview of the tests that ran. And then this is the detail view of each of these tests. So it says Fahrenheit to Celsius conversion. 32 degrees Fahrenheit should be 0 degrees Celsius. So the function that is supposed to do this did not return the expected result. And then you can see more information here. So this is actually some code in the tests. And this is all this stuff that we're seeing in the terminal outputted here it's like correlated to what's in here. And so you can start learning the language of testing. And it's mostly going to be the same, depending, like most testing suites are going to have a very similar syntax. So you pretty much just have to learn it once. And once you get used to it, it'll be familiar. So jest is a very common one for JavaScript. But most of them are going to have a very similar format. And the way that you write your tests is you import any functions that you want to test, or any classes, or even React components. And then you write your test suites. And so each test suite will be, you describe, so describe is actually, these are all things that are like all these keywords right here. These come from Jest. Jest makes all these possible. So these are like, this is code that these keywords are not valid JavaScript in vanilla JavaScript. These are special for using Jest, and we don't have to import them because Jest is actually the runtime environment. So Jest itself is like parsing the code. We're not using like the node interpreter to like turn this code into machine code. Jest is actually, I mean, Jest is using Node behind the scenes, but it's doing a first look at it to fill in what these things are. I think that's how it works. I haven't looked into it specifically. I just assumed. So yeah, the language is to write a test for a function. And how about I could do a new one. Let's make a new file and we could call it like my cool functions.js. And what's a cool function we could do? Maybe I'll get some audience participation. What kind of function could I write that would be fun to write and test? What should it do?
Simple add function.
You could just do like a basic calculator function. I mean, it wouldn't be too fun, but it would probably be pretty easy to test, like to start with, like if you're learning how to test.
Okay. Okay. Good idea. So we got a couple, and I saw I had a comment too. Okay, so we could do calculator, or let's do calculate, function calculate. Then we could do another one that's function numbers of pi. Okay. So calculate, how about this takes in num1, num2, and then maybe an operation. So you specify like what kind of things you can do for these numbers. And then we can say, let's do a switch case statement just to switch it up. We could do a switch for operation. And remember, if you haven't seen a switch case statement, it's like an if statement, except it's better for testing if a single value or if a single variable has one of a list of values. So you could say, if this variable is this, if this variable is this, if this variable is this. And so it's switch on that variable, and then each of the cases for, so switch operation, and then if operation is add, in the case that operation is add, then we can do return num1 plus num2. And you normally write break in between each case, but we don't need to do that if we're returning, because return will do that automatically. So we could do add, subtract, and multiply. And divide. And then the default case would be throw new error. And the error message will be operation not valid. And we could even tell the user what that operation they tried to use was, or operator. Oh wait, it is operation. Maybe we should call this operator. Operation is good. Okay. Operation, and then we could do like a string interpolation. Operation, and then whichever one they passed in is not valid. Okay. So that's this calculate function. So what should it do? It should take in two numbers and then add, subtract, multiply, or divide them. If you pass in the wrong operator, then it'll give you an error. Okay, numbers of pi. Let's say this function takes in a number and it returns that many numbers of pi. How could we do that? Return, I think pi is actually a global variable in JavaScript. So we could do return pi modulo. I could be totally getting this wrong. I probably am, but that's what testing is for. Wait, not math.floor. We just want to cut it off. I want to cut off pi at a certain number, a certain digit. Oh, wait, we do math dot.
We can do slice.
I think slice only works on like strings and pi is a number. But I think we could do dot you specify the JS I can't even think of the right words. Oh, float with certain precision. Yeah, to precision. Oh, to fixed. It'll round or pad with zeros if necessary. I think that's fine. Oh, does this return a string, not a float? Okay, looks like to fixed is how you do it, but people are having some issues with that. But that's a good thing for testing, right? It's good to have something that's kind of buggy if you want to test it. Okay. So we're going to return pi and we're going to do to fixed by the number you pass in. So this should return return pi to a certain number of decimals. So if you like pass in 3, it should be 3.141 maybe, because I assume to fixed is after the decimal point. I don't know. We'll see. That's why we're going to test it. So we have our index.test.js. I'm going to make a new test file that's like my cool functions.test.js. And if our jest config is set up right, then this should automatically work as a test suite. And so the language of writing a test is, well, first we want to export these functions so that they're available to the testing suite. So I can export calculate and numbers of pi. And then in here, I want to import functions from / my cool functions. And then we can do describe. And so describe, you use describe to basically say what a certain segment of your code should do. So you use it for, basically there's like certain levels that you split up your tests. Describe is kind of the like furthest out block where you say, I want to describe like a whole thing. So the thing that we want to describe here is that function. And the verbiage is honestly kind of strange in testing land, so you just kind of have to get used to it. So you say describe, and then what is the thing that you want to describe? You want to describe the function. I might get this wrong. So describe takes in an arrow function. I might have to double check. Okay, so the first variable is a string that says what it does, and then it takes in an arrow function. So first variable is a string, or the first parameter is a string. So describe, which function do we want to describe first? Let's start with numbers of pi. That seems, or let's do calculate, whatever. Describe calculate function. So here now, in here, we're describing what the calculate function should do. So what should it do? Well, it, and then this is the same syntax. You do a string is the first parameter, an arrow function.
Rio, I think it should be test instead of it, no?
It should be what? Sorry, could you repeat that? I couldn't hear you. Oh, test
Is it
instead.
better? Yeah, I think for just, I think, yeah, you write test instead of it in describe for
Okay.
testing.
Okay, good to know. Thank you. I think some of these, it could be that it is, I'm pretty sure I learned that it and test actually do the same thing, but it could be that I was using a different library before where I was using it. But yeah, test makes
Did you
more
use
sense.
Cypress or
Let's see.
Mocha
I've
chain?
used VTest and um I've mostly used Jest. So I'm pretty sure in Jest you can use it. Jest it. What is the difference? It is an alias of test, so they're exactly the same. Yeah. So that's what I thought. It's two different things that do the same thing. So you can either write it or test. But we'll write test just because that's what the demo does. Okay. So the syntax of these things, and I can put a little comment here. So the first one you write is describe. And then describe should take in, I'll do this as a comment here. Describe should take in a description, or just like the identifier. I'll just say what you are testing, comma, and then an arrow function. And then in this arrow function, you're saying test suites. So this is not the actual syntax. I'm just saying like that is what we're putting in here is the test suites. So that's the syntax for describe. Now this syntax for test is the exact same thing, except instead of saying what you're testing, you say what that thing should do. And then you're doing an arrow function. And then this would be a test case. So we have describe, and describe is right here, and it's full of tests. Describe, the first parameter is what thing you're testing. And then in test, the first thing is a string that says what you want it to do. So we could say calculate function should, and this will actually, when you, like I ran the tests in my terminal earlier and you could see it like outputted this stuff. This is made up of these strings here. Like the language that we use in the tests helps make our output here more understandable. So we could say test Fahrenheit to Celsius conversion. So that's what the describe block would output. So if I were to look at the describe block for those existing tests, describe Fahrenheit to Celsius, or test Fahrenheit to Celsius conversion. That correlates with this. So the testing library, it allows you to pass in these strings so that when you write the tests and you run them, when they show up in your terminal, it has this like language here that you can understand. So that when a test fails, you can see what is it that you're testing and what case failed. So that's what these strings are for. So we're saying the calculate function should add two numbers. Okay, so the first test case is we're going to verify that this calculate function can test two numbers. And so actually here, instead of importing all functions, I'm going to destructure it and I'm going to say calculate. And then I'm going to say, I'm just going to verify that this is, or I'll write the test. Let's write the test. Okay. So const result equals, and then we're going to call our calculate function. And calculate wants a number, and an operation. And you can see any. This is because we're using JavaScript and not TypeScript. If we were using TypeScript, it would say number, and then this would be a string of the permitted operations. So that is one of the benefits of using TypeScript that we're not getting here. I'm a big proponent of TypeScript, but JavaScript is great too. It's easier to just write stuff quick. Okay, so let's calculate. Let's do a hard one. 4 and 3. Because that's a tough one. And then we're gonna say add. So we're gonna add 4 and 3 together. And now we want to say, okay, after running this function, calculating 4 and 3, getting this result, what should this result be? Well, this is more syntax from Jest. You get expect, and you should expect result, and I might have to double check the language here. Yeah, expect result dot to be, and then what it should be. Well, what should the result of this be? 7. Right? If we run calculate and we pass in 4 and 3 and then the add, it should add 4 and 3. And so we should expect the result of adding 4 and 3 to be 7. So this is a fully formed test suite now. It's a test suite with one test case. So say this is a test suite which has multiple. For now, we just have one test case. So the test suite tests an actual like chunk of your code, like I say that, I don't just say function because sometimes you want to test a class or something else, but generally you're going to test a function. So what should this function do? Or what function are we testing? We're testing the calculate function. And then every one of these tests is going to respond or is going to refer to that calculate function. It's going to test some aspect of it. So the first case should be, well, it should add 2 numbers. And now we can run the test suite. I can run it because I have these extensions. I can run it by pressing these things, but we can also just run it by doing npm run test. And I'm hoping that our Jest is configured to where it'll pick up these tests, these new ones. Ooh. Okay, it's having some issues. Cannot use import statement outside a module. Oh, should I be using require syntax? Let's see. Yep. Okay. There's two different ways of importing stuff in JavaScript, and you will learn to hate that fact because it just makes everything harder. So this is a type of import that's supported in some environments. It's supported in React, and in the actual browser can use this syntax. It's called the ES6 import syntax. But the old way of doing it, and the way that Node originally supported, was the require syntax. And so the equivalent, it's complaining. I imported this using the import syntax when really I need to do the require syntax, which would be const calculate equals require my cool functions. And it'll even complain. It'll say, this is a common JS module. It might be converted. That's TypeScript complaining, but really it's telling me to do the wrong thing, because the right thing is to have require like that, and that should work. Yeah, okay. Oh, I might have done the wrong type of export too. Yeah, I think I'd need to do module dot export. So it's different syntax for importing and exporting. And I can't confidently tell you which way to do in any case, because you're going to get surprised at how many different cases you need to use different types of imports. Is React the only time that you use the import syntax? Nope. You use the import syntax, which is this one. You use this syntax in React. You also can use it in Node with certain configurations. You can use it in TypeScript with certain configurations. Once you start doing TypeScript stuff, this whole import versus require thing will literally make your head explode. It's the worst. I've spent literally days trying to get my app to even run because there's these different syntaxes. And it's because one of them, this used to be the only way to do it, and then this way got supported. And then everyone decided to kind of just do a weird mishmash of them. And when you have complicated build systems, which happens when you're using like TypeScript and React and Next and all this stuff, you end up running into problems when you're using, stuff like that. And you need to define stuff in your package.json sometimes. Like you can say type equals common JS or module, which says it basically allows different types of exports. So if it's module, then it'll allow a certain type of export. If it's common JS, it'll be another type of export and import. By default, it's going to be common JS. Welcome to JavaScript. That's just how it goes. All these different ways of doing things, and it can give you a headache. But let's try now. Okay. No more errors related to imports and exports. We're just getting our test suites failing, which, although it looks crazy, there's all this stuff, this is actually what we want. We're running the tests, which is good. These tests are all okay. So here's our test. Our test ran right here. And we can see test suites, 2 failed, 2 total, 4 failed, 9 passed. So we have different test suites. I think each time you use describe, it's considered a test suite, but it looks like it might be only each file is considered a test suite because it says there's only 2. Oh, or wait, yeah. It says there's only 2 test suites, so maybe the test suite is just a file. Either way, I want to not run the default tests in here for a second, so I can actually do .skip. So I'm going to skip all the tests in the default suite for now, so that I can just see the output of our test, because I want to show you writing a test from scratch and just get the, sorry, clear my terminal. Okay, so now it's only running our test here, my cool function test. So it says calculate is not a function. Okay, so apparently calculate is not a function. Let's console log calculate. I didn't plan that. I don't know what's going on. Let's see. Calculate is an empty object, so it's not properly importing. Utils equals require. Oh, okay. Calculate is going to have, okay, so this will be functions. This will import the entire file. And then we need to destructure const calculate from, or equals functions. So this will destructure calculate. It should. No. Maybe I did the wrong type of export. I probably did. Let's go to the index.js file. Module.exports. And in mine, I have module.export. Yeah, so it needs to be module.exports, plural. Hey, okay. So our function passed.
Cool.
So we got through it eventually. I know there was a lot of in-between stuff going on, but the parts to really kind of remember here, which I'll do another test, don't worry. But we are doing describe, and then you're describing some function, and then you're running a test. And then you run your test by clicking or by typing npm run test. And then if in your test, you can basically do whatever you want. You could, I mean, the really what you should do is at some point in your test, you say expect something to be something. Expect the result of calling some code to be something. And so we could write another test that says like test is true. And then we can test if true is true. Expect true dot to be true. So that I'm sure will succeed. So now we have two passing tests. So true is definitely true. That's kind of the main important point of the test, is that this describe and test thing are just kind of a way to like logically separate out different things that you're testing for, so that when you see it in your terminal, it looks like you can make sense of it. But the real important part is expecting something to be something. And there's a bunch of different ways to do this. There's like expect, and then there's like I could do expect and then see what kind of, oh, I'm not getting the TypeScript IntelliSense. Okay. Okay, let's write another test for our calculate function. So the last tests asked, or it tests if it can add two numbers. Let's test if it can subtract. So track two numbers. So we can say, well, I might as well just copy and paste it. result equals calculate, and I want to do subtract. And I want to subtract 3 from 6. And we can expect the result to be, what is 6 minus 3?
3.
3? Hell yeah. Did you guys say 4?
Well, if to apply theory of probability.
Oh, you did say 3. Okay. I thought you said, okay. Our test failed because I said 4, but okay. You're right. It's 3. Okay. Let's write a test for the pi function. Describe pi function. And then we do an arrow function. And then we do test. And then test has the same syntax. So a string for the first parameter. This says what the pi function should do. It should return like the first 3 values of pi when passed 3. So with your test cases, you should pretty much be like very explicit and test one thing at a time. Because like what we could do is we could write a test suite, like we could combine these two, right? I could say this is just like for good kind of like what do you call it? Just good practice when you're writing tests is make sure you do individual test case that test a very specific thing, like one thing at a time. You don't want to write a test case that's like test should work under all conditions or should work as defined. You don't want to do that. And then like have because you can have multiple expects. So we could say, well, the calculate function we could do add result. We could say expect add result to be what it should be, and then we could expect subtract result to be what it should be. Like you could basically write all of your like tests in one of these tests if you want. But that is bad practice. So don't test a bunch of different things, a bunch of different functionalities in one test. Because when something goes wrong in your code, you want to pinpoint exactly what it is that went wrong. And what'll happen if you write too many different things in the one test case is it will be harder to pinpoint what exactly went wrong. So did the add fail? Did the subtract fail? Or, what if you tested all sorts of different things in one test case? The test case will fail, but that doesn't necessarily narrow down very much what you want or what's actually going wrong. So don't do this. Don't test a bunch of different things all at once. Write individual tests for each specific thing. So we're going to test if the pi function returns the first 3 values of pi when passed 3. So const result equals, and then what is this function called again? Numbers of pi. So we're going to destructure numbers of pi out from functions. I think I can actually do this here. Like that. Numbers of pi, and then we're going to pass in a number. So 3 returns the first 3 values of pi when passed 3. So we're passing in 3. And let's expect the result to be 3.14. And this might be wrong. It might be 3.141 because I don't know how toFixed works, but that's a perfect example of why we're writing tests. Okay. Pi is not defined. And this is actually in the function numbers of pi. So that means I thought this was a global value in JavaScript, but I guess not. Oh, it's math.pi. Good thing we wrote a test. Okay. Apparently pi is 1.142. It's news to me.
It's rounding up.
Yeah, it's definitely rounding up. That's funny. So that means there's something wrong with our function. So sometimes you need to adjust your test case because you're like, oh, I wrote my test wrong. But the main reason for writing tests is you should go back and modify your code if it's not working as you expect. So toFixed is rounding up, and that's a problem. So, and that's probably what these people here were talking about when they were saying you could use toFixed, but it's buggy. Oh wait, buggy in Internet Explorer. That doesn't apply to us. Returns a string. Note, toFixed will round or pad with, okay. To precision, however, the number, I don't know. Okay. Let's try using to precision. Precision. Oh, and it might tell me. Returns a string containing a number representing either an exponential or a fixed point notation with specified number of digits. Okay, let's see what that does. I'll show you the next cool thing when you're writing your test suites. npm run test watch. So this will run our tests and we don't have to rerun it. It'll just continue running it. It'll continuously run. Okay. So now we're seeing our function is returning 3.1, or we're expecting 3.14 and it's receiving 3.14. It's still giving us, it's still saying that it's wrong. It's because it's returning a string of 3.14. So we actually want to return a number. And the way you can do that is wrap this whole thing in number. I think that should work. There it is. And I didn't have to rerun it because I did watch. I ran it in watch mode. Okay, so that is tests. And we could go and like all the tests that were already written in this project, I could unskip them. And then I could actually see what's going wrong in them and then fix these functions. So sure, I'll do it. Okay, so test Fahrenheit to Celsius.
Rio, can I ask a quick question?
Sure, yeah.
So if you would like to proceed with this stretch goal, so we have to, as far as I understand, open a new repo and complete the testing and then submit the link to new repo. It's not going to be connected to our
Yeah.
today's assignment link, right?
I don't think so. I think what you do is you probably have to fork it. I didn't fork it. I cloned it, but you should probably fork it. So you do fork. And when you fork it, you can rename it if you want, but you can keep it the same name. And this will create a copy of the whole thing on your compute or on your GitHub. A fork is different from a clone, or when you run a clone, it's actually connected to Code the Dreams version of it, where when you fork it, you would fork it and then it creates a new version on GitHub that's actually a fully separate, it's separate from the whole, from theirs. So when you clone, if I were to like make some commits and then try to push, I would be pushing to Code the Dreams version of it. Whereas if you fork it and then you clone, then you would be pushing to your own actual copy. So a clone will only create a new copy on your computer, but it's associated with the original one on GitHub still, whereas a fork is a fully new project within GitHub and you can clone it to your computer. So it keeps it fully separated. So yeah, you would want to fork it. And then pull it down to your computer and then fix these test suites. So you would run npm install and then npm run test. And if you run npm run test watch, like this, npm run test watch, that ensures that the tests will continue, they'll keep running over and over as you change the code. And then you can see how kind of, basically, I've been like interrupting the flow a lot, but I'll show you the actual kind of flow of when you're actually like doing what's called test-driven development. So you have some tests, they're failing, and now we need to go into the code and actually make the tests pass. So that's something that people will do is they'll sometimes define the tests before they even write the code. And if you do that, it's called test-driven development, which means I'm going to write some tests that assume that these functions are going to do something, and then I'm going to go in and actually write the functions so that the tests pass. And when the tests pass, I know that I wrote the functions, or that I did what I needed to do. So it's a way of basically like before you write some code, you might go, these are my requirements. Like I want a function that does this thing. And then you write a bunch of tests and you write like a stub for a function, which would look like this, like function do thing. And then it's just nothing. Or, you could say like return null or something. So this would be like a stub. And this function, you would now use that, you'd import it into your test suites. You'd write a bunch of tests that assume that this thing is going to do something. So you'd write a test that's like, well, it should, given this input, it should return this output. Given this input, it should return this output. Given this input, it return this output. And then you run npm run test watch, and then you go and you write code until the tests are passing. And so, in fact, why don't I do it? I'll do it in my cool functions. Instead of do thing, it'll be like, well, sure, let's have it be do thing and I'll just return thing. So, or actually it's going to still return null, right? But we're going to assume by the end of implementing this function, we want it to return thing. So I'm going to export it. I'm going to go to my test suite. And I'm going to say describe do thing arrow function test, and then again should return thing arrow function, and then I'm going to say const result equals do thing, expect result to be thing. Result. Okay, so now our tests should be failing. And let me unskip those other ones, or I reskip. I was skipping those, but then I unskipped. So let me reskip. Okay, so now I have one failing function. Do thing is not defined. Oh, that's a problem in my actual test suite. I need to import do thing and not import require do thing. That. Okay, so do thing, we expected to return thing, but it actually received null. So now let's go and fix it. Let's go to and this is test-driven development. So we wrote the test, and now we need to make this thing do the thing that we want it to do. So it received null, but it should receive thing. So I'll return thing. And look at that, it passed. Okay, so a very simple version of test-driven development. But when you have like, say you're writing like a server and then an app that's like a front end, and your front end is interacting with the server and you have all this complicated stuff going on, it can be really nice to just verify that, oh, the front end is receiving the information from the server, and it's displaying this, and then you can see the data displayed on the screen. So you can write a test that actually validates that, and then you can go and implement the actual code that makes sure that test passes. But let's make sure these tests pass. So we can start with test Fahrenheit to Celsius conversion. So we can expect utils.Fahrenheit to Celsius. So when you receive 32, it should return, or when you pass in 32, and it should say that here, right? Test Fahrenheit to Celsius conversion. So that's this function here. The test case that's failing that we're going to try to make pass is you pass in 32 degrees Fahrenheit and it should return 0 Celsius. So one way to make this test pass would be we could just return 0. That'll make that test pass, but then it'll make the other tests fail, right? Because if any of the other tests actually are good tests, then they are going to make sure that this function doesn't just return 0 at all times. So that's not the right way. So ideally, you should have a lot of different tests, and the tests should actually verify that things happen right. So we don't want to just return 0 to make that test pass. We want to actually do what this function should do. So takes in degrees Fahrenheit, should return degrees Celsius. Okay, so what it's doing is it's doing the calculation here, but it's not storing the calculation, and it's just returning degrees Fahrenheit, which you passed in the first place. So I'm going to say const Celsius, or like, I'm probably spelling that wrong. Degrees Celsius. Yeah, degrees Celsius. Oh, wait. Oops, being defined right there. Degrees Celsius, and then return degrees Celsius. Okay, and I know it's kind of hard to see, but that test is now passing, and it won't tell us. It won't be like, we don't get any crazy animation across our screen that says you now made that test pass. It doesn't actually happen like that. It's just we move on to the next test that's failing. I wish there was a better way to celebrate when test actually passed. Maybe that's an app idea. Someone should make an app that when your tests pass, or yeah, when you make a new test pass, you should get a little like animation across your screen that's like unicorns and rainbows and stuff. Like there's something like that in a Asana. If you complete a chore or something. I'll show you. Okay. Let's pretend that I learned Swift. This should do the animation, I think. Oh, no, it didn't. Okay, maybe I need to go to the actual page. Mark complete. Why isn't it doing it? Okay, I might need to go to the actual. Okay. No animation? Okay. Never mind.
Well, I kind of animated a box out of there in the design.
Yeah, there's usually like a crazy like unicorn that flies across the screen when you complete a task in Asana, but it wasn't happening. I don't know why.
That's neat.
I want something like that for when your tests pass. Okay, Grant has a question. Yeah, Grant.
Um, can I screen share? It's about the prop types.
Sure. Yeah,
Okay,
I'm
great.
about done. I feel like I've been kind of like losing steam with this whole testing thing, but I think you all get the idea, so definitely move on.
Okay. How do I do this? Notes, participants, AI. Um, well, lower hand first. How do I? Oh, screen share. It's the green button. Advanced. Just why isn't there just one that just says, "Hey, show whole screen"? Portion of the screen. Share. What is happening?
Looks good. I can see your VS Code.
Yeah, I was trying to make the box bigger there.
Hmm.
Okay. So what do you see currently?
I see um, your browser and your code.
Okay, cool, cool, cool. I just wanted to confirm that I was doing this correct because I was in California last week and didn't really do the work. So I just wanted to make sure this is right. You're supposed to do it for the function that's you're using it on, correct? So I'm in the add to do form, the add to do function, and then at the bottom you put the prop type. You also import it, which it is, and then you just add the thing, and that's it. That's all you do.
Yep. And if you, yeah, you already imported the library, it looks like.
Yeah.
Yeah, that's all you do. And now to verify it, which as I think Amanda demonstrated, you can verify that it's working by going to your app.jsx and you can try passing in something that isn't a function into on add to do. So
Oh,
if you go
so
there and you try passing in like a string,
okay, so like, right, you can just pass strings as a prop, correct? Oops.
yeah,
I can just change the text to like a string. Where did it go? What happens? Ah, everyone gets stage fright when the string's on.
I know. In the hot seat.
Greg. And then go
Oh,
back here.
no, it should be giving you an error. I don't know why it isn't. Um,
Yeah, on add to do. On add to do. Huh.
maybe I don't know, maybe you'd have to reload your window for it to work or something. I'm not sure.
Okay, so
Yeah, don't worry about it. I think you're doing it right. I'm not seeing the benefit at the moment,
Okay.
which should be it should be verifying that you're passing in the right props in the actual implementation, which it's not for some reason.
And that's essentially all this week's lesson is to just go into all the files and just add the prop types.
Yeah,
Yeah.
from my understanding, yeah, that's all you got to do. Um, and I think let's see. Yeah, the
You can
unit
also do,
testing is
yeah,
optional.
optional.
Yeah. Yeah, so you improve your project structure by just dragging everything into a new folder called components and updating your
Yep.
imports. And
Hmm.
then you add the prop types to everything, and then you should be good.
Okay. So I guess the question is, how do I fix it so the squiggly lines appear? Because that, I guess it defeats the point if you don't get a visual
Yeah,
representation.
I am not quite sure. I I feel like that's what I was expecting to be the default behavior, but it hasn't seemed to be working right, so I'm not sure. Um, yeah,
Error, error lines.
I'd say don't worry about it.
Okay.
And in the future, a lot of you will probably learn TypeScript at some point, and you might hate it and you might love it. Um, but TypeScript basically it's has all
Oh,
this good stuff built in.
I forgot. React is made by Facebook, and Facebook just does a bunch of open source stuff currently.
Yep.
I forgot about that.
Facebook also made Jest, I'm pretty sure,
Oh,
the testing library.
not to get
Um,
all. It's kind of cool seeing a big company like just do a bunch of open source stuff.
yeah. Well, I wouldn't say it's necessarily out of the kindness of their hearts, but maybe.
See that I see. I didn't want to go that route. I was just trying to be nice. Big company doing nice things for the tiny people. You the one who brought it up. I didn't say it.
No, it probably
But
is. That's probably just a good thing for the world that they're open sourcing. I don't think there's anything wrong with it. I think it's
okay.
good.
So that's essentially it. It's just going to each file and then finding the props that it's using and figuring out what they actually are and then denotating them down here.
Yep.
Okay.
Yep.
All right, I can do that tonight. That I thought this was going to be. It always feels daunting. It always feels like certain concepts are daunting until you like understand what they really are, and it's like, oh, okay, no, that's kind of simple as a thing. So thank you.
Yeah. Yeah, that's how a lot of coding goes, is sometimes it takes 5 hours of research to do something that's just like 2 lines of code. You're like, oh, I had to, spend a long time to figure out how to actually understand what I needed to type. And that's how it goes sometimes. But yeah, once you
Okay, what?
got once you get that one, you should know how to do the rest.
Okay, well, the question then becomes if there isn't going to so like okay, so how would I know if I've done it correctly if there isn't going to be like any like pushback on it? So like let's say I just oh, this is not the right one.
You don't.
So I could just go array and then it's like, yep, that's totally fine. Oh, did I save it? Yes. Yeah. And then nothing happens and I'm like, oh, okay. So, huh.
Yeah, I think there's no like real feedback for doing that, which that's the surprising part for me. But
Okay. I just I just wanted to know
I'm gonna give you the go ahead that uh, if if all of you do exactly what I demonstrated there and what Grant has there, if you all get like Fs on your assignment because you did it wrong, I will personally go through and fix all of your assignments for you. So
I appreciate it. I just I don't know, just you want to work with things that I don't know. I feel like with code, especially because down here, like it always like gets angry if something's wrong and messed up, and then to have like a
Hmm.
piece of functionality that it works question mark it just
Yeah.
feels weird.
Yeah, I agree.
Thank you
I like
though.
your to-do app. Looks awesome.
Yeah, I oops, there it goes. Yeah, I feel weird about it because it's part like most of it I did, but then I couldn't figure out how to do this where it deletes. So I asked ChatGPT and I felt bad
Ooh,
because
yes
I
and
don't.
no. That's cool.
Yeah.
You should get a
Uh,
little hover animation so that
e
when you hover over the to-do, it like uh makes it look like it's a button that's going in a little bit.
yeah.
Maybe that's misleading because the whole thing isn't actually a button.
So I definitely will go back and then I haven't done the CSS stuff. I kind of just hit it real quick to get something down, and so I'm gonna go back, highlight it and make it. Oh, that was the screen for the thing, and make it adaptable. As you can tell, it looks wonky when it gets smaller. But yeah, it's getting along. I just need to work on it, and also while doing the rest of the assignment, and I'll be fixing up the CSS thing.
Well, it looks great. And I see looks like you're having fun with it, which, that's awesome. Making it your own.
Yeah, thank you so much.
Yeah. All right. How's everyone else feeling? Thinking about wrapping it up here. Any last questions or comments, concerns?
Thank you for explaining things so clearly again, for breaking down complicated concepts and teaching us a new skill.
Yeah, of course. Happy to help.
Yeah, I really appreciate it.
Cool. Well, yeah, go forth and test your code, or you can do the test thing if you want. I could show you testing actual React components, but that's for another day. Um, Basically, when you're testing a React component, you have to use another library. You have to use
Uh-huh.
Jest, and then there's another library, or you can use vtest and then React testing library, and you'll basically say render this component to the screen, and it like simulates. You don't actually get to see it, but it does simulate rendering the actual DOM. And then you check for certain things on the screen. So you'll say, render this component and verify that this text appears on the screen. Like hello world should appear somewhere on the screen if you render this component. Or for the to-dos app, it would be like, and you can even simulate mouse clicks, which is really cool. You can
Neat.
say, uh, click on the button, like find the button and store it in a variable. You can do find button that says delete to do, and then store that in a variable, and then say button dot click, and it'll actually like, or I don't remember if that's the exact syntax, but it's something like that. And it's pretty easy. You basically simulate rendering the browser, like rendering your
Uh-huh.
actual components in the browser, checking to see uh, if that component actually exists, if it holds the text you imagine. You can check the CSS styles, and you can simulate the user clicking, and you can simulate like navigating to different pages, and you can test and verify that like so that's a much more like you're testing much more than just a simple function. You're testing this whole kind of uh
User
thing, and
interface.
yeah, and it's pretty cool.
So I when I was looking at Jest yesterday, it kind of reminded me of Selenium, which is more specifically like a front end. Um, what was it called? It was in a thing today. The end-to-end user thing, that's what it's called, where like you're basically doing
End-to-end
all the things.
testing.
Yeah. And I was just wondering if like Selenium, which is specifically just clicking on things on the actual website, is that still like a beneficial thing? Because I had like learned that as a toolkit during my previous job, and I was just wondering if like that would still be beneficial when you're trying to just test out repeatable things for users to do, or like learning just because it's going to be more like specifically ingrained into React might be more beneficial.
Yeah, good question. I don't have like I personally have never done like real end-to-end testing,
Mm.
which, that, I mean, you have a certain amount of time to learn certain things, and that's one of the things that I just have not gotten to yet. But that is definitely an important thing. There's three kind of different categories of tests. There's unit tests, which unit tests are the one we just did. It's testing a very small unit of your code. And then there's integration tests, which are like a little bit more high level than that. And then there's end-to-end tests. And end-to-end tests would test like um, entire processes in your app that include like actually rendering it to your screen, and it'll like do clicks and stuff, and it might even do like a login form, and it might test like to make sure your front end is interacting with your back end. And um, I don't know. There's like different levels of tests, which are more fine-grained or less fine-grained. And so unit tests are the most fine-grained, and then end-to-end tests are the most like broad. So an end-to-end test would be like, you know, Facebook might have one that's like it tests creating a new profile, and it actually like runs through and actually does the whole process of creating a new profile, and it interacts with their actual databases and all that stuff. So um
So like something like Jest because it allows you to actually interact and check if the code's actually doing something versus Selenium, which, the only types of checks you would have is based on what type of text is on the page. Because when I used it, like you could make it fill out a form and then you would just have it check the DOM to say if you had like whatever text on the page, like login successful, and then like you
yeah.
just say if this text is on the page, that passes that form of the check. But what you're saying is something like Jest is actually like saying, okay, the database was hit, the database did this, we're good.
um
Kind of?
well, Jest is actually more unit test specific
Mm,
from my understanding.
okay.
It might have more than that, but I think Selenium, I'm not sure. I don't know much about Selenium, but I do know there's one called Cypress that I've heard of, that I know Cypress is end to end.
There's Cypress, Playwright, and Selenium.
Okay,
Those are the
player.
three.
Yeah. Okay, yeah.
Yeah. You've
Yeah.
used Playwright and Selenium before. And
Okay.
mostly with Selenium, it's either getting things to actively be clicked on or using like document select query or something a little bit more complicated to click on to just drill directly into it, or at least that's how I did it. And then,
Yeah.
you like when you say if else this inner HTML is blank, that's how to continue on. If not, then do something different. I guess that's not it is testing, but technically you're just like making sure very like your website flow is specifically the website flow you want. I guess that's the best way to explain it. But I only used it for like a month or two when I was testing out something last year.
Yeah, that's interesting. I'd say you probably know way more about it than I do. But it's cool. There's like all these different kind of levels that you can test your code at, and it's important to, in like a real world application, you'd want to have different tests at different levels. The unit tests are easiest for just like well, first of all, you might have thousands. Like a lot of code bases will have thousands of unit tests that test every single function for, you know, and there's something that you'll hear of called test coverage, which it's like there's actually metrics that look at how much of your code base is actually being tested, like how many pieces of your code are actually being tested. And so, you might strive for test coverage of like 80% or 90%, which means all the, 90% of the code in your application has specific tests that ensure that it works correctly. And there's a use case for all these different types of tests. And um, unit tests are great for test-driven development. That's one of the things they're really great for, which I showed you just the very beginnings of, which is you write the test and then you actually go and implement the code. And as you're iterating on your code, you're getting instant feedback. Does it work? Because the test verifies. And then once your code works, you know that it works. You're not going to continue making changes and then have accidentally stumbled upon the solution, but then you didn't realize. You'll have your tests constantly running to make sure that your code is correct. And you'll likely have more and more tests that build up over time. And then when you're changing one part of your code base, it might break other tests. And so the nice thing about having a bunch of tests and all of your code being tested is that when you add one new feature, if it breaks another feature, then the tests for that feature will fail. And so you'll know to go back through and fix those. If you're a big app like Facebook, say they add something new to the user's profile, but then that breaks some other thing, like for, maybe you add a new button on the timeline view, but then when you go to the actual profile view, that button isn't showing up anymore. And actually there's some function that expects it to be there, and then everything crashes and it breaks. They would have tests that verify that like every part of their code still works. And there's this thing called continuous integration. You might have heard the terms CI and CD. So there's continuous integration and continuous delivery. Continuous integration is the practice of, they're both like part of like Agile, or they're part of like DevOps, which DevOps is like it's like a series of practices to make sure that like larger like companies will employ when they're like trying to build apps and run their developer teams and have everything go smoothly. So continuous integration and continuous delivery is part of that. Continuous integration means every time you push your code into GitHub, every time you push a branch into GitHub and you have like a pull request, there will be automatic tests that run that verify whether that code is working. And so you'll have actually in GitHub will actually have servers that run your code for you and do all the tests. And so anyone who pushes code up to the server, if you're doing like a code review, you can see, oh, the tests passed or the tests failed on this iteration of code. And then you can even have it set up to where it doesn't merge. You can't merge code where the tests are failing.
Oh.
And then if you have continuous delivery set up, continuous delivery means every time you merge into the main branch, like if you merge a pull request, that version of the main branch will immediately get deployed. So there's like your deployed code, and then there's your main branch on GitHub, and they might be like correlated in a way to where every time you push into your main branch on GitHub or you merge code into your main branch on GitHub, GitHub will automatically send that code out to your like development servers or your deployed servers. So like your databases, your APIs, your front end, like the actual like deployed code that you have, whether it's deployed on like, web servers or in the cloud, it's usually in the cloud. Your main branch, every time your main branch gets an update, your code will be deployed out. So you don't have to like manually go in and go to the servers and actually like put the code into your servers. Your servers will automatically get the code pushed into them when you update the main branch on GitHub. And that's continuous delivery, is every time you update your code on GitHub, the production branch gets updated with that code. And then that's continuous delivery. And then continuous integration means every time you push your code to GitHub, it runs a bunch of tests. And so both of those together make CI and CD, which means your code is always being tested. And anytime you try to push code into the main branch, you can't push it into the main branch if it's breaking, if the tests are failing. And if the tests aren't failing, you can push it into the main branch and then it'll automatically be deployed. So it's this whole kind of practice that programmers do where it's an easy way of like iterating on their code and making quick deploying new updates quickly. So like you might notice like in the App Store, you have updates constantly. You know, if you go to the App Store on your phone or whatever, like there's probably updates almost every time, unless you have automatic updates turned on. But lots of apps get updates pretty much every single day. And there isn't a person manually updating them because that would be a lot of work. It would be annoying. And so the way they have that set up is every time you merge into the main branch, it goes to the App Store. It actually like deploys your code to the production places. And you can't deploy or you can't put it into the main branch unless the tests are passing. So that is one big reason for having tests is that they can automatically run on GitHub. And if they're automatically running on GitHub, then you can have one branch of your code, the main branch, automatically deploy when it gets updated. So automatic tests make sure that your code is always working. Automatic deploys make sure that when you want to integrate your code with the main branch, you ensure that it's always the tests are all passing and that it can automatically be deployed. So, anyways, huge rant over, but that's kind of the context. That's the main context you'll hear. Testing is, or that's one of the big pieces of it is continuous integration and continuous delivery. Okay, I'm tired of talking. Bye, y'all. Thanks for coming to my TED Talk.
Thank you so much.
I'll see you next time.
See you next time.
Hi,
Okay.
Ryu. Thank you.
Bye.
Thanks, you.
Next
Yep.
week.